MEI Statistics Minor Bivariate Data 3 Lines of Regression 3.2 Using the line of regression for random on non-random data. We're going to use the same example as the previous video. So we're doing a Hooke's law experiment where m is the mass being controlled by the experimenter and L is the length of the spring. When the data is random or non-random, the regression line predicts the theoretical true value of the random variable from the non-random variable. So if our data looks like this, our regression line will go through the center like that. And that will be estimating the true length of the spring for a given mass. The theoretical true value being one with no experimental error. We might then be asked to use this. So estimate the length of the spring when a weight of mass 4.2 kilograms is placed on the end. So the GCSE method that we used to use is we'd locate 4.2, we'd draw a line up, then we'd draw a line over, and that would be our prediction, that the length would be approximately 29 centimeters. In A-level, we now have a method to find an equation of the regression line. We found it to be L equals 21.3 plus 1.91 m in the previous video. So if we're given this problem, all we need to do is substitute in m equals 4.2. In your calculator, we get, rounding to a sensible degree of accuracy, we can also go the other way. So if Simon needs the spring to reach a length of 30 centimeters, and we need to estimate the mass he will need for this, simply sub in L equals 30 and solve. And round. Explain why it is inappropriate for Simon to use his model to predict the length of the spring when a weight of 10 kilograms is attached to it. Well, if we increase the size of the diagram, we can see that these points are the only evidence we have, and we can see that it is linear in this region. So anything between those values is what we call interpolation. However, outside these points we don't have any evidence, and that is what we call extrapolation. So anything over that side is extrapolation, anything in here is also extrapolation. So we don't know if the data is going to continue in a linear fashion, or if it's going to start decreasing, or if it's going to start increasing. There's also physical factors to consider. What about when it reaches the maximum length of the spring? There may be an upper limit that value of L simply can't go above. What about if there's a breaking point of the spring? Again, that would be an upper limit. So the answer is that the weight of 10 kilograms is going to be extrapolating, and we can't say for certain what is going to happen in the extrapolation range. In the next video, we're going to be looking at residuals.